Alright, today we're looking at negative exponents. So to kind of give us a lead in, let's consider looking at this two different ways. So if we have x squared over x to the fifth, what we really have is x. And what happens here is that we simplify by canceling two x's from the top and two x's from the bottom, leaving us with 1 over x to the third. The other way to view this problem is that x squared divided by x to the fifth, we subtract exponents, which gives us x to the negative 3. Same problem, done two different ways. If we look here now, 4 over 2, 1, 2, 3, 4, 5, 6. Cancel, 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 cancel. Divide by 2. Divide by 2, we are left with 2 over x squared. If we look at it from the division standpoint, 4 divided by 2 is 2, x to the fourth divided by x to the sixth, x to the negative 2. So again, same problem, done two different ways. So what's the key idea about this? These are the exact same things. So a negative exponent, if you have a to the n power, that's the same thing as 1 over a to the negative n. Vice versa. If you have a to the negative n, that's the same thing as 1 over a to the n power. So moving exponents up and down changes them from positive to negative. So if we have 2 to the negative 3, that's the same thing as 1 over 2 to the third, which is 1 over 8. If we have 1 over 2 to the negative third, we bring that up, we make that 2 to the third, and that is 8. Right? So it's the idea that if you are negative in the numerator as an exponent, you're positive in the denominator. If you're negative in the denominator, you're positive in the numerator. So I want everyone to get used to, with all problems with negatives, whenever we see a negative, we just want to reorganize. So the 8 has an exponent of positive 1, so that's staying. The 4 has a negative 3, so we drop that down. The 2 has a negative 2, so we bring that up. So really here, we have 8 times 4 over 64, which gives us 1/2. Alright, so every time we do a problem, we want to start by reorganizing the problem. Right? We always want to make the negative exponents positive. That's my biggest piece of advice. So we want to simplify, if possible, and always make the negative exponents positive. So if we look at some practice problems, right, I start this problem off. I'm just going to move the negative down from x to make it x to the third. I move the 5 up, 25 over x cubed. Now with this problem, we got two options. Right? Two options to go with here. Right? You could first give out the negative exponent. You could simplify the inside. Or a third option we'll get to in a second. Right? So based on what we've known, I think the best way to go about doing is starting on the inside. Cancel the y's and move this down. So now I have y squared over x squared to the negative third power. So in this situation here, I could give out the exponent, y to the negative 6, x to the negative 6, which would flip-flop to be x to the 6, y to the 6. But, as I said before, there's a third option here. At this spot right here, with this negative exponent, instead of distributing a negative exponent, we can flip the entire fraction and make the exponent positive. Right, so really, if we wanted to right here, with that negative, we could have rewrote this as x squared, y squared, all to the third power, which would have given us this. Alright, the reason is because if you give out a negative exponent, at some point you're going to have to flip things due to the negative aspect of it. So instead of giving it out and then flipping, we can make it a little bit easier, I think, flip and deal with the positive exponent. Alright, moving on to the back. So same thing here. right? I put a star next to it because I want us to look at that new rule. With the new rule, 2x, 9y to the fifth, I'm just going to make it up. I messed up. I didn't flip anything. Forgot to flip it. Alright, so with the new rule, 9y to the fifth over 2x all to the power of 4. Alright, so I got rid of that negative exponent instantly. I give out my exponent. 9 to the fourth, y to the 20th, 2 to the fourth, x to the fourth, which gives me here 6,561 y to the 20th over 16 x to the fourth. Now, did I have to do this step right here? No. You could have taken this problem a different way. You could have given out the negative exponent and then worked from there. Either or, perfectly fine. All right. So, what am I doing? Negative 6 to the third, m to the third, n to the ninth, p to the sixth, times 1 over 2 m and p to the third. So here I got negative 216 m to the third, n to the ninth, p to the sixth, times 1 over 8 m to the third, n to the third, p to the third. All right, so with this setup here, as we've learned about in previous units, we can cancel on the diagonal. So I can get rid of the m to the thirds. I can get rid of this n to the third and make this an n to the sixth. I can get rid of this p to the third and make this a p to the third. And I could simplify my numbers. 8 goes cleanly into negative 216, leaving me with negative 27. For my final answer, negative 27, n to the sixth, p to the third. All right, problem 5. What am I thinking right away? Flip it. I'm not going to work with a negative. I'd rather work with a positive. Give out my exponent. 27, x to the 6th, y to the 9th, z to the 3rd. All right, problem 6. All right, so I look at this one, I'm thinking right away reorganize. But before I do that, y to the 0 is 1. That is irrelevant. So I have 4, x to the 5th, 8x to the 6th, y to the 1st, z squared comes down, z to the 3rd. I can do my simplifying. Get rid of 5 x's, leaves me with x to the 1st. Combine these to give me z to the 5th. Divide by 4, divide by 4. Final answer, not 2. Final answer here, y over 2 x z 5. All right, last two problems here. So again, I'm looking at this, I'm reorganizing. 21 m6 over 3, the p squared doesn't move. All right, what moves? Y to the 7th, p to the 11th, y to the 5th. Over here, the 7 doesn't move, the y squared doesn't move. P to the 7th, m to the 6th. All right, so I reorganized it, moved everything around, got everything to be positive. All right, so I can divide by 3. Oh, and then I can go diagonal, divide by 7 to get that. All right, so I've gotten rid of all the numbers in the situation. Now I have m to the 6th and m to the 6th. That's gone. I got y to the 6th, and this would leave me with y to the 1st. I can combine these p's to make it p to the 13, cancel p to the 7, and that leaves me with p to the 6th. I feel like I'm missing something. What am I missing? So what do we got now? Looking here, I got y to the 5th over p to the 6th. I feel like I made a mistake. Drawing a blank for a second. Let me just look this over. So I have y, let me do y squared. Oh, caught my mistake. Alright, little error. This should just be a y squared. Alright, gotta fix that up. That's y squared. So I cancel this, I'm left with y to the 5th, cancel that. Great. So then my final answer here is 1 over p to the 6th. Sorry about that. Real-time filming leads to some errors, right? But the key thing is that, I'm able to realize here that, with all the work, things happen, and take your time, make sure you practice patience and organize things correctly. All right. -8, x to the -3rd, y to the 6th, which is -8, y to the 6th over x to the 3rd, plus, I'm going to flip this right away, 2y squared over x to the 3rd power, 8 y to the 6th, x to the 3rd. All right, good thing here. We have the exact same fractions, we have the exact same common denominators, we have the same variables. So in this situation, we combine, and we are left with nothing.